and also pull up all the console. This is SW1. This is switch 1, switch 2, switch 3, switch 4. Sorry to hope it might be the font might be a little bit small, but I just try to let you see the diagram while we configure all of them. This is Cisco switches and Cisco. I think the Cisco devices and the Cisco style, this CLI, you're pretty familiar with it. This is kind of like an industrial standard, and all the other vendors just have pretty similar CLI interface. Just enable and just go to the privilege. We call it privilege mode. This is a standard user mode. Is privilege mode. You can do everything, and just configure T and the host name, and just SW1. Yeah, just can change the host name for convenience, and the same thing as this. And we just look at this diagram, and there's Ethernet interface name. So we just configure those interface name and also create this VLAN, these 3 VLANs on all 4 switches, because normally we use BTP, VLAN trunk protocol, to transport those VLAN database, but now we didn't mention the BTP from the last lesson, so just use transparent mode to create this VLAN, 3 VLANs on every switch, and also just you can see just VLAN 10 and give it a name, guest, right? VLAN 20, give it a name, library, and VLAN 30, and give it a name, just give it a name, and server. Okay, that's how you create the VLAN, and you just can type in do show running for running config. You can see we're using 50.2 iOS, layer 2 iOS, layer 2 layer 3 iOS, and also there's some default configuration. Those are default configuration. You can see that this is a interface name. For example, this E0/0, E/0. There's nothing here under here, and also and the VLAN database is separate data. It is not shown in the configuration or running config. So, but you can show VLAN. You have 10, you have 20, you have 30. That's what you if you want to modify. We have interface E0/0. We have range. That means the range means E0 to 0/1. So we have to give the common configuration for this 2 link. So the switch mode, trunk mode, encapsulation .1q, and then just this command just define the .1q as trunk encapsulation. Then we just type in switch mode, trunk, and OK. So because we define these 2 as a trunk, and also we have a channel group, right? We have channel group. So we wanted to assign these 2 physical interface into the trunk group. The trunk group 1, and the mode on. You can just type a question mark for all the options. There's active, passive, for LACP negotiation. Auto and desirable for PGP, another negotiation protocol. We just give it on for manually on, just statically on, no any negotiation. That's on. Oh, sorry, it's on. Yeah, and this port channel 1 is automatically created on this switches, and it's done. As you can see, the port channel is up. You can exit and do write, just write, save the configuration. And another one, you just E.0.2, comma, E.0.3, switch mode, switch trunk, encapsulation, .1Q, and switch mode, trunk, and no shutdown, because sometimes some specific iOS by default the interface are shut down. You have to enable it by using a no shutdown. This is a no shutdown command, and also E.E0.3 by looking at the diagram, and just switch mode and switch trunk encapsulation .1Q. And switch mode, trunk. Okay, no shutdown, and just exit to off. Sorry, just okay, because there's pretty much the same. And also give a E.0, 1/0. Sorry, this you have to give this interface some appropriate configuration, because this interface, as I said, there are some options for interface. This option is switching port. You just type switch, and it just type mode, access mode. This is access port, access port, and access VLAN. What this you just assign a VLAN ID for this port. Because the server, we can see server is belong to VLAN 30. It's just VLAN 30. No shutdown. Right. Just save all the configuration. You just gave. And the same thing, I think same configure for switch 2, switch 3, and switch 4 is all total the same. So just pause the video and just I don't want to take too much time. I just pause the video. Okay, all 4 switches configuration were done. I just give it a layer 2 configuration, because I wanted to clarify, and just you have to figure out the layer 2 configuration and layer 3 configuration, because the focal point and the technologies are totally different. So you use practically speaking, or in your real projects, you have to separate them. I just tried to quickly verify the configuration result. For example, they just like we show VLAN, just show what VLANs we just created 10, 20, 30, and also here for switch 1 we put this physical interface, assign this VLAN ID to this physical interface, which is connected to the server. So it's for switch 2. Oh, sorry, just forgot something. Just show trunk, show interface trunk. So you can see that we as we configured either this is either channel. We just put these 2 physical interface into port channel. This is port channel's name is port 1. Port 1's trunk mode is on. Encapsulation is L2.1Q. It's trunking. Native VLAN is VLAN. A native VLAN is I didn't talk about native VLAN, but you can refer to some of the book to just for some details. And a VLAN allowed on trunk. This is pretty important. That just if you want to restrain some specific VLANs running on this trunk, you just give it the explicitly gave those VLAN IDs. If you don't give any VLANs, you just want to all of the VLAN are permitted. For Ethernet 02, Ethernet 0/2 was to switch 3 for 0/2 switch 3, and for 0/3 for switch 4 to switch 4. It's all okay, and the VLAN allow. You can see that this kind of things to show the VLAN status, trunk status, and show VLAN. Show VLAN to check your VLAN, and this is one, and this interface is bound to VLAN 10, and so interface trunk to see this Ethernet 0. There's a different Ethernet 0/3. Actually, this one. But this what is called? This is refers to we're just representing is negotiate the L2.1Q. It's not you configured explicitly. Just negotiated result, and other is the same. Just hold up this 3 VLAN and show interface trunk. You see it is all okay. For switch 4, interface trunk, it's okay. Oh, VLAN spanning tree forward now prompt. So switch 4, 3, 2. Okay. VLAN. And then we have okay, just another things I want to mention or just point out is spanning tree. So you can see, because by default, spanning tree, IEEE spanning tree is enabled, so you can just show spanning tree. So all of the spanning tree status will be shown here. Because Cisco has this pro VLAN spanning tree, that means that every VLAN has its own spanning tree. So you can see that this is a VLAN 1 spanning tree. This is a VLAN 10 spanning tree. Because we create, by default, VLAN 1 is enabled. And we just created VLAN 10, VLAN 20, and 30. So you can see that VLAN 10 had this VLAN status, spanning tree status, and this bridge is the root. So you remember that we went through the election spanning tree election process, and this is a root bridge, and some of the timer for spanning tree, because and the interface is forwarding and forwarding for VLAN 20 to also forwarding, because this switch is root bridge, so all of the ports are forwarding. And then we go like we head over to switch 3 and show spanning tree for VLAN, for example, VLAN 10. You can see here Ethernet 0/3 is a blocking, right? It's a blocking because if you notice this diagram, they have a lot of loops from connection perspective, from topology perspective, they have so many loops. So as for the result of the spanning tree, some of the physical port will be blocking. For example, like this is a blocking port. If something happens where topology changed, this blocked interface might be change into forwarding. So this state machine or just this kind of like a transition need some of the timers to control this transition. So that's why there's some of the transition timers here. So for switch 4, it also shows spanning tree. You can see VLAN 1 spanning tree. You can see the VLAN 10 spanning tree also have some blocking port. Because switch 1 is root bridge, so that might be switch 3, switch 4 is a furthest switch. So they have the result. They have some of the blocked port interfaces. That's a spanning tree status. For spanning tree, you can verify and check out. And I'm gonna go ahead and just continue configuring our layer 3 configuration. Because the switch 1 is only one that has layer 3 function, so all of the configuration will be configured on this switch. So just interface VLAN 10, and there's no shutdown, and IP address. Give this SVI or virtual interface VLAN interface a IP. VLAN 10 belongs to guest VLAN. Guest VLAN is 10.1.1.1, and net mask is 255, triple 255, and no shutdown. No shutdown. And interface, and just interface 20 IP address. This 20 is librarian. It's 10.1.2.1. No shutdown. And give it a VLAN 30, which is for server. Server's IP is 10.1.10.1. This one. No shutdown. Loop complete. So all done. Let's verify this connection to see if it's okay. And just right click or just double click on the server. And here this is simulator of a server. And you just, if you don't know the CLI command, just type help, and you just give it IP, or just IP question mark, and IP, give it IP 10.1.10.10, and /24, and give it a default gateway, 10.1.10.1 as a default gateway. 10.1, and just return pin 10.1.10.1. Yeah, here it is. You can see the pin is successful. Right, that's pretty nice. And move on to guest 2. Just pause the video and just save. Okay, guys, I just finished all the configuration for all 4 endpoints. Server, guest 2, guest 1, and librarian 1. So give them a appropriate IP and a gateway. So just try to pin server from guest 2. This is a guest 2 console. I just pin 10.1.10.10. So you can see that the pin is okay. The communication is working now. And then we just pin others. For example, pin library 1. 10.1, 2, 10 is also works. So that's the routing in